We are studying different elemental length, surface, and volume at different coordinate systems. First, we consider the Cartesian coordinate system. You see here, it is x-axis, y-axis, z-axis. We consider one elementary volume whose this side is dx, this side this side is dy in length, and this side is dz. Dy, dx, dz are elemental. So differential length in Cartesian coordinate system, which is denoted by dl bar, is given by x hat dx plus y hat dy plus z hat dz. That means if you start from this point or the point somewhere inside here, you come in this side by distance dx, go this side dy, and go this side by dz. Then the point here and this point, if you assume a line, this is x hat dx plus y hat dy plus z hat dz. This is called elementary length in Cartesian coordinate system. Next is differential surface element or elemental surface in Cartesian coordinate. Here you can see in this elemental volume, we can say this is what is the volume? Volume is this side is dx, this arm is dy, and this side is dz. So this elemental volume, the volume is dv equals to dx dy dz. This is the elemental volume in case of Cartesian coordinate system. Now it has 6 surfaces. 2 surfaces are pointing along x direction. This surface is pointing along x hat direction. The other side, the surface will point in the negative x direction. Where similarly, this surface is pointing along y direction. This side surface will pointing along negative y direction. This surface is pointing along z direction, and the bottom surface will pointing along negative z direction. In the vector study, we always associate area or surface with a direction, and the direction of the surface will be such that it will be perpendicular outward to the volume. Perpendicular outward to the volume. This is the volume. This is the perpendicular to the surface and going outward. So in vector analysis, we see the area is considered as a vector and its direction is perpendicularly outward from the volume. So this surface has a direction x hat, and the magnitude of this surface is this is dy, this is dz, so this is dy dz. So the 2 surfaces are there. One surface is x hat dy dz, another surface direction will be minus x hat dy dz. Similarly, dsy, this is the elemental surface which is along y direction. It will be y hat dx dz. This side is dz and this side is dx. So it is y hat dx dz. Y hat dx dz. Two elemental surface will be here, this side and from this side. One will be positive y hat direction, another will be negative y hat direction. Similarly, the elemental surface along z direction, that is ds suffix z, this vector is this arm is dx, this arm is dy, so it will be the magnitude of the surface will be dx dy and then along z hat. Similarly, one of the surface will be in the bottom side, whose direction will be along minus z hat, and the magnitude will be dx dy. So 6 surfaces are there. Here you can write plus minus x hat dy dz, plus minus y hat dx dz, plus minus z hat dx dy. These are the 6 surfaces. So we have elemental length, elemental surface, and elemental volume, or somebody says differential surface, differential distance, differential volume. These will require at the time of vector integration, line integration, surface integration, volume integral. When we do this, we will use this elemental length, elemental surface, elemental volume. What happens if the system is represented in cylindrical coordinate? In this coordinate, the elemental length is defined as this is a suffix r hat means it is along r direction. This is the r direction. This is the r direction. So this is an elemental volume whose this arm length is dr. This arm length, we know when this length is very small. When this length is very small, we can consider it as a straight line. We can consider it as a straight line. But this is r distance, and this angle, this small angle is d phi. This small angle is d phi. So the this is d phi, and this distance is r. So this arc will be r d phi. You know this. This is arc by radius equals to angle. So arc equals to angle into the radius. That is r into d phi. D phi is this angle. D phi is this elemental length, elemental angle. So this is r d phi. This is r d phi. R d phi is one of the arm. dr is one of the arm. R d phi and dz. This is dz. This, though it is appearing like curve, but when it is very small, we assume this is as straight line. This is a straight line. Okay. So elemental length will be dl is dr along r hat. R hat means here it is represented by a suffix r. So when I am saying r hat means it is a suffix r hat. That means unit vector along r direction. Unit vector along, this is the along r direction, or this is the along r direction. Okay. Earlier we have told you that the r direction is radially outward from the z axis in cylindrical coordinate system. Next, it is r d phi along phi hat direction. That is a phi hat. A phi hat denotes the unit vector along phi direction, plus dz along z direction means unit vector along z direction is represented as a suffix z hat. Hat indicates the unit vector. So this is the elemental length in the cylindrical coordinate system. Here you should notice that it is not just d phi, it is r d phi, because d phi is an angle, r d phi is the elemental length along phi direction. R d phi is the elemental length along phi direction. Here when what is the volume? Elemental volume, it will be dr into dz into r d phi. So dr into d phi into dz, these are r d phi, the r comes first. Okay. Now 6 surfaces, here also 6 surfaces are there. 6 surfaces are, one surface is having in the directed along the radial direction. So this surface is r hat, this arm is r d phi, and this side is dz. So r d phi dz. So it is one of the surface is along r direction, that is a suffix r hat r d phi dz. The other side, in the opposite side, there will be one along the negative direction of r hat. So you can write here plus minus. So two surfaces dsr are plus minus a suffix r hat r d phi dz. Similarly, one of the surface is, that means this surface. You can see this surface. This surface having the direction along phi hat direction. And what is the area? It is dr and it is dz. So ds phi equals to phi hat dr dz. Phi hat dr dz. This should be here phi hat, instead of phi hat it is represented as a suffix phi hat. Phi hat and a suffix phi hat are identical. So there will be this side which surface is perpendicular to the phi direction. The other surface will be in the perpendicular to the negative phi direction. So there should be a plus minus a phi hat dr dz. The last one is which is perpendicular to the the surface which is oriented towards the z axis. This side is r d phi and this side is dr. So it is d s suffix z is z hat r dr d phi. Z hat, here z hat is represented by a suffix z hat r d phi dr. You should write here plus minus because this is one surface, the bottom surface is another surface. So in coordinate cylindrical coordinate system, what are the different types of elemental length, elemental area and elemental volume we have learned. Here you know r, theta and phi, their range r can be extended from r is in this direction, so r is extended from 0 to infinity. Z limits z can be extended from minus infinity to infinity. This is not 0, this will be minus infinity to plus infinity, and the phi limit is from 0, which is along the x direction, to 2 pi. Okay. Next, we want to understand what is the line element, surface element, volume element in spherical coordinate system. If I take a little volume in spherical coordinate system, you can see this is along the r direction, and this length is dr. This length is dr. Okay, and this direction, this length, this is theta, this is r, and this is d. So this will be, this length is r d theta. Now this is the length r sin theta. So this length is r sin theta. This length is r sin theta d phi. This length is r sin theta d phi. This length is r sin theta d phi. So elemental length will be dr along r hat plus r d theta along theta hat plus r sin theta d phi hat. Here E suffix r hat is equivalent to r hat. E suffix theta hat is the theta hat. E suffix phi hat is phi hat. Okay. Now the surface, 6 surfaces are here also. This surface has direction towards the r direction. So what is this length? This length is r d theta. What is this length? This length is r sin theta d phi. And this side is r d theta. So it will be r square d theta d phi sin theta. This is the one of the side. The other side will be minus r square sin theta d phi r e suffix r hat. Okay. Similarly, this surface, if I consider this surface, it is along theta direction. This direction is dr, and this length is r sin theta d phi. So dr r sin theta d phi. Okay. So there will be another. This side is positive. The other side will be negative. So there will be a plus minus sign. You can write this. The another surface is this one. This surface direction is minus phi hat. But if you consider this surface, this side will be along phi hat direction. So this arm is r d theta, and this side is dr. So it will be dr into r d theta, along phi. This will be again plus minus. 6 surfaces are already covered. Now what is the volume? Volume is this is dr, this is r d theta, and this is r sin theta d phi. So r into dr into r d theta, into r sin theta, then r square sin theta d phi. These are the elemental length, surface and volume in spherical coordinate system. Okay.